In addition to the base plotting system, the other main mode of plotting for R is through the lattice package. So remember, recall that the lattice package uses the grid package to create a different style of plot from the standard base package. And the main difference between lattice and base is that the lattice functions generally create plots all in one go, rather than kind of creating the foundation of a plot and then adding points or adding text or adding annotations or things like that. Most of the functions in Lattice will try to construct the entire plot from a single function call. So the main functions in the Lattice package are the XY plot for creating scatter plots, BW plot for creating what are called box and whisker plots, or just box plots, histogram for creating histograms, strip plot is kind of like a box plot but with points instead of the boxes, dot plot, SPLOM, which stands for scatter plot matrix. This is analogous to the pairs function in the base graphic system, and then level plot and contour plot are for plotting image data. The basic approach of lattice functions is that the first argument is usually a formula of some sort. And the formula can look something like this. So here I've got y tilde x. So you can think of y as being the response of some sort. So it's going to be on the y-axis. X is the input, or so to speak. It's going to be on the x-axis. And then the solidus represents conditioning on f and g. And f and g are typically going to be factors. So here I've got two different factors that are interacting with each other. There won't always be two different factors. Often there'll just be one. But the idea is that the strength of the lattice functions is that you can plot conditional relationships where you condition on the relationship, say, between x and y based on a third factor variable. So, for example, f might represent a factor variable categorizing men and women, and you might want to look at the relationship between x and y for both men and women separately. So the lattice function is very useful for that kind of for plotting that kind of data. So the lattice functions will usually take a data frame as a second argument, where the variables y, x, f, and g will be looked up to find their values. If there's no data frame passed, then it will look into the parent frame to find the values of those variables. So lattice functions behave differently from base graphics functions in a very critical but subtle way. So the idea with base graphics functions is that they plot data directly onto the graphics device. In more formal language, this is called having a side effect. So all of the base graphics functions have a side effect, which is that they plot data to the graphics device. Lattice graphics functions are a little bit different because rather than plot something to the graphics device, what they do is they return an object of class trellis. And so they don't actually plot anything particularly. All they do is they create an object that is designed for plotting, and they return it to you. And that object has a special class. It's called trellis. And then what happens is that when you print that object, the print method does the work of plotting the data to the graphics device. So when you call a lattice function, what happens is that even if you don't assign it to an object, the result of that lattice function will be auto-printed. And so the auto-printing will generate the graphics onto the plot on the graphics device. So it will look like things are just being plotted and that the lattice functions have a side effect, but rather the returned object is auto-printed to the graphics device. Now, in theory, what this means is that you can kind of save the object that's returned by the lattice function and maybe save it to a file or something like that. But usually that's not a very good idea. It's usually better just to save the code that created the object and the data that are inputted. Lattice functions also have a critical feature called the panel function. And so when you condition on a factor variable in the formula, there's going to be a separate panel created for each level of the factor. So for example, if you're conditioning on a factor variable that encodes gender and it has two levels, male and female, then what's going to happen is that you're going to have a plot that has two panels, one panel for males, another panel for females. And the panel function controls what happens inside each of these panels for the entire plot. So here I'm simulating some data, some normal data that have a linear relationship, and I'm going to create a factor variable that has two groups labeled group 1 and group 2. So if I call xy plot for y tilde x and then condition on f, this is the plot that you get.
So you can see that there are two panels, group one, one for group one and one for group two, uh, and and all that happens within each panel is the scatter plot is created. Now I can modify my plot by adding a custom panel function. So in the previous plot, I just used the default panel function, but I can create my own panel function by writing this little anonymous function here. And the first two arguments are going to be x and y. So you can think of those are the x coordinates and the y coordinates of the points that are going to be plotted in a specific panel. So it's not all of the data that you pass to the xy plot function. It's just the data that appear in a given panel. And so what I'm going to do in my custom panel function is I'm going to call the panel.xyplot function to just plot the data points and use all the default options. So all the default options are getting passed through the dot 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 argument. But then I want to add one extra thing, which is I want to plot the median of the y values in each panel. So here I'm using panel.abline, and I'm calculating the median of y, and I'm going to specify a line type of 2. So here I'm going to plot within each panel. I'm going to plot the median of y in that panel, and it's going to be a dashed line. So here you can see that I've used these two functions, panel.xyplot and panel.abline. You might recall that there's another function just called abline, which is used in the base graphics system, but you cannot use functions from the base plotting system in a lattice plot. So Lattice, for better or for worse, has duplicated many of those types of functions in its own version. So you have to call the panel.abline function instead of just the abline function. In the previous plot, I just added a horizontal line for the median of y, but suppose I wanted to add a regression line for each of the panels in my plot. So now I can call my custom panel function after plotting the points with the panel.xyplot function. I can call the panel.lmline function, and here I'm specifying that I want the regression line to be of color equals 2, which is going to be red. So here the panel.lmline function just adds a regression line to each of the panels.